Hello everyone, Mr. Fitcher here, bringing you Lesson 2 of Unit 2. If you recall, our unit here is about rocks and minerals. Last time we talked about minerals. This time we're going to talk about classifying rocks. So let's get into it here. Our objective for today is, how do geologists classify rocks? Okay, like our minerals, how do geologists tell the difference between rocks? 3 vocabulary words here. First of all, weathering, the effects of freezing and thawing, plant roots, acid, and other forces on rock. Second one, erosion, the process by which running water, wind, and ice carry away bits of broken up rock, small little pieces of broken up rock. Sediment, these are small, solid pieces of material that come from rocks or living things. Okie dokie. Our first objective here. How do geologists classify rocks? All right, you see that our main category there, rocks, is broken up into subcategories, which are then broken up into other subcategories, okay? And we're going to look at each of these today. So, first of all, we need to understand that geologists observe the rock's mineral composition, color, and texture. So they're looking at what is unique about these rocks and how do they differ, just like they did for minerals. Our first step in classifying rocks is looking at the mineral composition and color. We need to understand that rocks are made up of a mixture of minerals and other materials. Some rocks contain only a single mineral, while others contain several. And what is important to note is that there are about 20 minerals that make up most of the rocks of Earth's crust. About 20 minerals. And we call these rock-forming minerals, because they're going to comprise most of the rocks in the crust. Now, we're also going to look at the rock's color, because this provides clues to the rock's mineral composition. Now, very much like our minerals, the color alone does not provide enough information to identify a rock. So we can't just look at a rock or a mineral color and say, this is this rock or this is this mineral. No, we have to look at a few other factors. One of those other factors is the texture. This is the look or the feel of a rock's surface. Most rocks are made up of particles. These particles are small pieces of minerals or other rocks, and we call these small pieces grains. And we describe the grains using the grain size, the grain shape, and the grain pattern. So if you look at the rock examples I have pictured here, you see that there's different colors, In particular, I want you to look at the small black pieces in each rock there. Those are the grains I'm talking about, So those are the small particles, the small pieces of minerals or other rocks that make up this rock, And we can look at them even more closely to see how big they are. Do they have unique shapes? Do they form a pattern in the rock? This will tell us about the texture and help us figure out what type of rock it is. Okay? Now, next, the origin of the rock. Okay? This is the way the rock was formed. Okay? These are our subcategories, which we're going to look at again. Okay, we've got igneous rock, forms from the cooling of lava and magma. Sedimentary rock forms when small particles of rocks or the remains of plants and animals are pressed together. Now, these form in layers and are buried below the surface. Metamorphic rock forms when a rock is changed by heat and pressure, by heat or pressure, or by chemical reactions. Okay? Again, most of these form deep underground. Okay? So let's look at this a little more closely. Again, igneous rocks, okay, form from the cooling of lava or magma on or beneath Earth's surface. Okay? Remember, lava and magma, molten rock, okay? Rock that has been heated so much that it turns into a liquid. Now, this differs here. Igneous rock differs, okay? We've got, first one, extrusive rock. This is lava which is hardened on the surface, okay? So, molten rock that is on the exterior of the Earth, okay? Lava is on the surface of the Earth. Whereas below Earth's surface, we've got intrusive rock. This is magma that is hardened beneath Earth's surface, right, in the interior of the Earth. Okay? Now, many igneous rocks are hard, dense, and durable. Okay? Again, the texture depends on where it forms, okay? Rapidly fast cooling lava forms fine-grained igneous rock with small crystals or no crystals at all. Now, again, lava is on the surface of the Earth, and you have to think about this. Lava cools rapidly because the exterior, the surface of the Earth, is much cooler than the interior, the inside of Earth. Okay, so it's going to cool really fast. Whereas slow cooling magma, okay, cooling inside of the Earth, forms coarse-grained rocks with large crystals. Okay? Now, what do we use this for? Well, mostly building materials and tools. All right? Granite is an historically famous building material. If you look to the left, we've got a granite countertop in your kitchen. And then obsidian, as an example, is good for tools, cutting tools especially. Again, if you look to the right there, we've got some obsidian arrowheads. Okay. Next here, we've got sedimentary rocks. Sedimentary rocks are formed through a sequence of processes, weathering and erosion. Once this happens, the following occurs. Okay? Deposition. The material is deposited in layers. Okay? You see this in the picture to your right. Okay? First one. Next one. Compaction. Layers of sediment build up over millions of years, and the weight of these new layers squeezes the old layers tightly together. Okay, it's pushing them down and pushing them tighter together. Finally, cementation. This is when dissolved minerals crystallize and glue the particles of sediment together. Okay? So we see that picture to the right, where small pieces of rocks and material are deposited in the water, as an example. Okay? Over time, those layers build up, compacting, pushing, squeezing those layers together. And then finally, those minerals and crystallize and glue those particles of sediment together. Now we have three different types of sedimentary rock. First are clastic rocks. This is sedimentary rock formed when rock fragments are squeezed together. An example here is sandstone. These are mineral particles, and shale, clay, and mud mixed with mineral particles. We've got organic rocks, forms where the remains of plants and animals are deposited in layers. Two examples: coal, dead and decayed plant matter, all right, and limestone. These are the skeletal fragments of marine organisms, okay, fish and other things that live in the water. Finally, we have chemical rocks, where minerals dissolved in a water solution crystallize. Okay, so three different types of sedimentary rock. And again, I would show you these examples if I could. We will do that when we're back in school. All right, what do we use sedimentary rock for? Well, again, tools and also building materials. You see the flint and chert spearheads and arrowheads at the top. You also see the sandstone buildings like the White House in America, where the president lives. That's a sandstone building. And I just included a picture of Minecraft because obviously you know that there is sandstone to be found in Minecraft as well. Last type of rock here is metamorphic rock. Okay? This forms when a rock is changed by heat or pressure or by chemical reactions. Okay? Now, metamorphic rocks form out of igneous, sedimentary, or other metamorphic rocks. Okay? So you're taking existing rock and you're changing it through heat and pressure. Okay? Now, while metamorphic rocks are forming, this intense heat changes the size and shape of the grains or mineral crystals. Okay? Now we have two types of metamorphic rock. First one is foliated. Foliated rocks describe the thin, flat layering found in most metamorphic rocks. Okay? Now I want to emphasize that when I say the thin, flat layering, you see that picture at the bottom. You'll be able to see these layers, okay? They'll be quite clear, just like that cake there. You see the different layers of the cake. You see the different layers of the foliated rock. An example of this is slate, okay? Non-foliated rocks, though, these are the mineral grains that are just simply arranged randomly, okay? No layering, no rhyme or reason, okay? You see that example there at the bottom as well, and an example of this is marble. Okay? So, what do we use metamorphic rock? Well, again, we use it for buildings, statues, and carvings. Okay? An example here is let me get this correct, the Ananta Samakon throne hall. Okay? That's made out of marble. Okay? It's not too far from school. And we've got roofing as well, and other building materials. Okay, slate is a historically used roofing material. Okay, and to finish up here, the rock cycle. Now, the rock cycle describes forces deep inside the earth and at the surface that produces slow cycle that builds, destroys, and changes the rocks of the crust. So you see here in this picture how sedimentary rock, metamorphic rock, and igneous rock are created, okay, whether through heat and pressure, melting, weathering and erosion, compaction and cementation, okay, and how they're destroyed, okay, and how they change into other types of rock. So again, we could go through this, but I think if you look at the picture, it will pretty much adequately describe what you should understand about how these rocks are created and destroyed. Okay. So again, how do geologists classify rocks? Our objective review, again, we've got 3 categories: igneous, sedimentary, metamorphic, with several different subcategories. Now I won't go through them all again, you can go back and review them, but just note that those subcategories are created uniquely, okay? And again, just like our minerals, we use the information that we know about the rock to classify it. Okay, was it created by magma or lava? Was it created from once living plants and animals? Okay, was it changed by heat and pressure? That will determine what type of rock it is, and also the importance of them. Okay, so this concludes our unit. Again, we will go back once we're in school and look at these. We'll be able to hold them, examine them, and then classify them, all right, using the information we know in a lab experiment. All right. If you have any questions, as always, feel free to ask. Otherwise, I will talk to you in our next class. Thanks.